Welcome, everyone. Thanks for joining us. In today's session, we'll be highlighting Morningstar's newest advancements in off-grid solar system control and integration. Just a few quick items before we get started. During the webinar, all attendees will be muted for best audio quality. If you have any questions throughout the presentation, please feel free to use the Q&A button at the bottom of your screen. Joining us today is Kyle Wilsey, Director of Sales at Morningstar Corporation. Kyle brings over 15 years of experience across technical sales, engineering, and business development, and leads Morningstar's industrial business across North America. His focus is on driving growth in key markets like oil and gas, telecom, transportation, and security, while advancing the company's solar technology solutions. Over his 13 years with Morningstar, Kyle has played a key role in strengthening their position as a global leader in solar charge controllers and inverters. Kyle, it's great to have you with us. Feel free to take it away.
Thank you, Amber. Appreciate that warm introduction. Yeah, 15 years with Morningstar. I've been here since the days of the SunSaver launch into the Gen 3. There's a lot of history. Today we'll cover a bit of a look down memory lane, look at our professional series controller line, just kind of give everyone a overview, a bit of a crash course in sort of where we've been, which is still very relevant today. A lot of our products have gone through a lot of change in terms of firmware and improvements, and so I don't want that to get lost. But we are very excited to discuss our integrated series, some of the new advancements we've made, primarily on the larger charge controller formats, the GenStar series, and introduce you to our Ready Edge product and all the enhancements that brings to the rest of our product line. This is the kind of rough overview of the flow. We'll do that professional series overview quickly, maybe spend 10 minutes or so on the GenStar and the integrated series, and then get right to the heart of the matter, which is the Ready Edge and the Solar Connect cloud platform that comes along with that. I guess I should say, as we go along, if there are questions, I'm happy to answer as we go. Travis is going to be joining us, or is here, joined us to help triage that a bit. It's always tough to manage both. So, but if there are questions, Travis, just feel free to stop me as we go, and we can cover them in the course of the slide deck as opposed to waiting at the end. But we will have some time at the end as well for any Q&A that comes up after the fact. So to start, just jump right in. This is a nice overview of where we've started over 3 years, 3 decades rather. The SunSaver line is what we're known for on the bottom left there. The SunSaver brand itself, I've found over the years at trade shows, folks often recognize that before they recognize Morningstar. So pretty strong controller range in that smaller class, 6, 10, and 20 amps, and then we move up to the ProStar. The ProStar is both a PWM and an MPPT controller, and our TriStar range up to 60 amps of output current at 48 volts. We've been around for over 30 years. This is the 33rd year. Actually, I believe it was last week, we celebrated the 33-year milestone. Over 5 million controllers fielded in that time. We have a really large presence both in North America, US and Canada, and in every corner of the globe. And I've had the privilege of bringing Morningstar's engineering and just overall name for quality to those corners of the globe in the markets that Amber mentioned, primarily telecom, oil and gas, security, transportation, to name a few. Anything industrial in nature is really where we shine. And as I said, we take a lot of pride in the quality of the product because we know that it just needs to work wherever it ends up in the field. I won't bore you with a detailed view of every year since '93, but there's been a lot that's happened since that SunSaver was introduced and the ProStar early '90s, mid '90s, all the way up to the GenStar today. The controller, regardless of when it was designed, what its specific technical specifications are, it's really there in the system to prevent overcharging of the battery. That's where off-grid battery-based systems all started. Someone realized it would be novel to use a solar panel as a charging source, but making sure that the battery isn't overcharged became, the first order of business. We also prevent against undercharging if the solar system if the solar system is insufficient or the load is drawing too much. The charge controller's job is to balance that flow of energy and maximize battery life. I take a little bit of issue with some of the marketing terms that are out there around the notion that somehow the power electronics in the system can magically, lengthen or increase battery life. I like to say maximize because, that's a practical, really a practical phrase that just denotes that we're going to do everything we can within the bounds that we're given to get the most out of the battery over the course of its lifetime. You have to deal with heat. The depth of discharge plays into that. So we're taking into account all those factors and just trying to do the best with what we have to make the most out of the investment in the battery. Big part of that is load management. LVD is typically what comes to mind when we talk about managing primarily DC loads in an off-grid system. That's built into almost everything we do, as well as managing the charge into the battery. It's just as important to manage the outflow and have that tuned correctly to avoid over discharge or discharge in suboptimal temperature ranges. And of course, being the central part of the system, the charge controller is there to give the user or the operator, indication of the health of that system, the status of the solar inputs, any other inputs that might be there, and the battery itself. A lot of what we do, going back to the first Modbus enabled controller we produced back in the early 2000s, is to have an open data interface, and that becomes really important for our oil and gas customers. Our Modbus kind of baseline serial and Ethernet Modbus interfaces is really important to integrate into various industry standard remote monitoring platforms, and in particular, SCADA systems. But at the core, every controller is effectively, doing the job of charging a lead acid battery. We are seeing obviously a shift to lithium in a big way, but this is still sort of the baseline of our business in the industrial world, although that's changing. And so whether the battery is flooded, VRLA, gel, AGM, everything that you'll see throughout the presentation is, let's say, compatible with any of those lead acid battery chemistries, using a standard approach that can be fine-tuned. There's nothing to our controllers that can't be adjusted. Pretty much an open book when it comes to choosing how you want the parameters to be set. But even if you use a preset, it's following some variation of this general bulk absorption float approach day in and day out. When it comes to lithium, things are a little bit different. Obviously, we, in some ways, think that charging lithium batteries is a bit easier. It's more simplistic in terms of the control that's required. We deliver a certain amount of current at a specific voltage until the threshold is reached, and we cut off charging. This is a slide that I like to point out, is really not intended to be an exhaustive list, but when lithium became more prevalent, we were getting a lot of calls. Maybe a decade ago, they started to trickle in, and now it's mainstream. We began to work with brands and manufacturers just to take the guesswork out of charging lithium batteries. And so this is not an exhaustive list of all the names that, let's say, are compatible with Morningstar. They're just some of the brands and manufacturers that we tend to work more closely with in terms of documenting, the approach to fine-tuning a system around that particular battery interface. But any lithium battery, whether it's LFP, NMC, LiFePO, they're all compatible. We can customize any of our data-enabled controllers to manage those batteries, and as we'll get to toward the end of the webinar, even get into some pretty sophisticated closed-loop battery BMS interfaces that bring some pretty unique opportunities to off-grid systems. So to the way we look at our catalog, to just kind of break things down by technology, PWM, pulse width modulation, is still very much a relevant technology. Generally smaller systems, sun savers, sun lights, sun keepers, sun guards, sun saver duos, all have some flavor of PWM controller in the catalog, and they tend to be, let's say, 30 amps and under. The TriStar comes in a 45 and a 60 amp output. These are all common in that they share the same design approach. They're all solid state. There's no mechanical relays. Many of these controllers are epoxy encapsulated. The Sunkeeper in particular is IP65 rated. So for a let's say a mid price point or a lower price point, PWM really still gets the job done for a lot of systems, especially in industrial sites where they just need to work. There doesn't need to be a lot of indication, let's say, or just they're standalone and rarely attended. So they're just basic chargers that do the job of getting energy into the battery and preventing that overcharging. The Sunsaver being the standard, it's been in the same three. It's come in the same three current outputs for many years: 6, 10, and 20 at either 12 or 24 volts. The factory presets are, I like to just say, either a high or a low setting. 14.1 volt set point on the low side and 14.6 on the high side. There is a change coming later this year for the first time in a long time with the Sunsaver range. We'll be introducing another SKU, or actually a handful of models that are both 12 and 24 volt auto select in one package. They are all the same form factor, same hole location, so kind of a mix and match approach to the smaller PWM charge controllers. This is the flagship in the hazardous location rated range, suitable for Class 1 Division 2, ATEX rated systems, and the like. The same is true of the ProStar. This is again kind of a legacy product that has undergone many generational updates over the course of those 33 years. The legacy model being shown on the bottom, which I'm sure there are some of you out there that still have these in the field that are working just fine. But this kind of newer version, Generation 3, has been out now for 8 years in both a 15 and a 30 amp model, and it is a 1224 auto detect. Um, this is the first part of the range that offers an LCD display. And with that LCD display comes some configurability on the meter. So this is a really nice option when you need to be able to fine tune or configure custom settings, charge lithium, or set a controller or system up for lithium. Even in a retrofit scenario, that could come in handy. But a really core part of our product line that we still support and have certainly no intentions of changing anytime soon. Um, the Modbus data interface is the ProStar brings the Modbus data interface kind of at the lowest price point and the lowest current level. So under that terminal cover, you'll find a serial Modbus interface that brings a full Modbus spec to a pretty affordable price point. And then just moving up to the TriStar, this is again tried and true workhorse. It's been in the market for over 20 years, undergone countless firmware updates and improvements. Covers everything from 12 to 48 volt battery based systems, either in a 45 or a 60 amp output option, also with Modbus, and sharing that same kind of heritage of no moving parts, all solid state, very reliable, robust heat sink, robust thermal management. The next catalog zone is the MPPT controller range from the Sunsaver up to our 600 volt controllers. The Sunsaver MPPT is both a small format 15 amp output controller, also building in a Modbus interface and remote temperature and voltage sense inputs. Also comes with a hazardous location rating, so it is suitable for applications within the hazardous zone in an oil and gas field. Really solid product. It has undergone an extensive improvement in firmware as well over the years, but is still very much in production and finds its way into a lot of systems even today, being kind of small on the power range. Moving up to the ProStar MPPT, you have a 25 and a 40 amp output option, both at 12 and 24 volts. The input voltage ticks up a little higher to 120 volts open circuit max, and comes in both a LCD and a non-LCD option. So again, for field programming or adjustment of various set points, it's really a versatile controller that covers anything from about 3 to 400 watts of input power all the way up to maybe 1200 or even 1500 watts on the high end. Here's just a quick look for anyone that's doing systems or building systems for gas and oil field. Over the last 5 years, at various times, we have gone through certifications and recertifications for these models that you see here to be covered for that hazardous location rating. From the Sunkeeper and the Sunsaver down to the 6 amp range, up to the 40 amp ProStar, they're all covered. They all have that same Intertek ETL listed mark. And then for some international markets that utilize a similar system, you see that EX and that IECX rating. It's all covered under the same Zone 2 classification. And just a quick note, when you do use a Morningstar controller in a hazardous location, any related accessory that's used in coordination with a controller is also covered under that listing. That's a question that comes up sometimes. So as long as you're using an approved certified controller, whether you need a communications adapter or an RTS cable, those are all covered under the listing, and we can provide that documentation if needed. Just to round things out, the TriStar PPT for many years was sort of our biggest controller, 48 volt output and up to 3,200 watts of power at the battery bus. It also comes in a 30 and a 45 amp version, three different SKUs within that same family. It was the first controller that built in all of our, let's say, open protocol data interfaces and physical hardware interfaces. So within the faceplate under the meter that's displayed, you can see, or you would see rather, an RS-232, RS-485 Ethernet. So it's a pretty well-rounded controller that still serves us well. And later this year will be, for the first time, we'll see a Generation 2 TriStar and PPT that will have a bit of a different look to it, similar in terms of its power class, but a lot more capabilities that dovetail with the integrated series that we'll talk about in a moment. Also, I would be remiss if I didn't mention the 600 volt version of that product. This was really a pretty revolutionary idea when we came out with this back around the time I started with Morningstar. It was on the drawing board, and 8 or 10 years ago became a very versatile addition to the catalog. Allowing you to maintain that same 48 volt output, but at a much higher input voltage. Um, Really important or handy, I should say, as a kind of a design flexibility option. If you're running long distances from an array to a battery bank, whether it's through a clearing in a forest or just because of the nature of the site. We've seen a lot of mountaintop sites that require longer distance wire runs from the solar array to the battery bank, and this is a really nice tool for those kinds of applications. If I could summarize, one thing about the whole range that we've discussed, it's this graph. As an engineer, this tells me a lot about Morningstar's design philosophy. And this is a curve, if you looked in the back of our manuals, that you would see consistent across all of our MPPTs, certainly, and down into the PWM class as well. When we set out to design a controller, it is going to operate at a very high efficiency across the whole output power range. This is unique to Morningstar. A lot of alternatives will sort of tend to fall off or trail off across the power range, whereas Morningstar's multi-phase design allows us to keep that efficiency high even when the output power is at its, let's say maximum rated output. And generally above 95%, almost always above 97 typical, and in some cases 99% peak. Kind of our claim to fame. We're pretty proud of it. We think this is really hard to see in practice. You don't always look at the milliamps being saved by the thermal efficiency and the power conversion efficiency that's built in and engineered into every MPPT, but it matters in the long run for that longevity of your battery life. And that's one of the ways that we keep the most amount of energy from the solar array flowing into the battery is by using less in the process. With that, I'll change gears a bit and talk to the integrated series. The integrated series is the newest. When we launched the GenStar and PPT 3 years ago, back at SPI, I believe it was, we we felt that because there was so much that was different from the rest of the line that it belonged kind of in its own category. Because it really is more than just a charge controller, it is a DC system controller. We've embedded a lot of I/O. We've embedded a novel ready rail system that we'll talk about into one chassis and one platform to give a much more compact approach to building systems for industrial use. That GenStar core, let's call it a platform, was designed to be, both a charge controller and also a management device for all the various inputs and outputs that we typically see in a system. So from that platform, from the GenStar platform, whether it's a 60, an 80, or a 100 amp charge controller, you also have the ability to monitor the system through various open protocols and dashboards we'll talk about. You also have an option to control outputs in ways that are unique to this product line that you can't get with a TriStar or a ProStar based system in the form of this Ready Rail expansion system that we'll also chat about a bit. Um, and we also give you an immense amount of flexibility on how to manipulate the output to charge various battery chemistries, even to connect with BMSs from various lithium battery manufacturers directly in a closed loop scenario. There's a lot packed into this product. I'm only going to be giving you a quick crash course. So I did want to mention that there is a deeper dive webinar in a few days, just about a week away, where we'll be going into the details of the latest firmware update, the 4.0 firmware update that unlocks even more functionality to the GenStar. So tune in for that if you're looking for a deeper dive. In particular, that will be focusing on the cloud connectivity. Morningstar Solar Connect is the Morningstar cloud platform that is enabled through the GenStar directly, no additional hardware required. Just through a firmware update, it will become enabled even on hardware that was produced, 3 years ago. It's a pretty unique product and is only being enhanced by that software investment that we continue to make. So here's the overview of the product itself, just really quickly. A lot of input oversizing capability. We certify everything in the integrated series up to 150%. It has that very high power conversion efficiency that I mentioned. Um, any battery chemistry, whether it's lithium, NiCad, nickel metal hydride, you see that very rarely, but sometimes, and any kind of lead acid battery. So it's a universal compatibility charger. We include a 30 amp load control output that is, different from the professional series. The TriStars, for example, don't have that built in. So within the confines of the footprint of the GenStar, you get a 30 amp LVD circuit that can be monitored and manipulated remotely. And as I said earlier, either a 60, 80, or 100 amp output. All of them have the same 200-volt open circuit input. They all share the same footprint, the same heat sink design. And most importantly, I think, is that they all have the same open protocols, data interfaces, and uniquely a Bluetooth interface directly from the core product. So through that firmware update, you now have access to the Morningstar mobile app. You also have, if you're not able to use any kind of proprietary software or radio, because of various constraints in an industrial environment, that can be disabled, and you can use the industry standard hardware interfaces like the RS-485, 232 Ethernet. I like to just kind of pause here because this encapsulates really the core value proposition of the product. When you set out to design a system for an industrial application, even within the rest of the Morningstar catalog, typically you're having to integrate products from across various, lines or accessories. And the purpose of the GenStar is to build that all into one box. Not only does this save cost, right? Effectively, it's a cost saving mechanism, but it also reduces the risk of failure. All of those connections, if you think about, the alternative of building a system with external wiring and cabling and crimping terminations and torque specs on terminals, that all creates potential for issue over time. Even if it's done perfectly on day one, it requires maintenance. And so by building it into one product, you increase the resilience of the system before looking at any of the other benefits. So I think it's worth pointing out that fact as a consideration to look at an integrated series product, but also just the simple fact that it takes up less space. There's less configuration, less labor and assembly. So it's in our view kind of the culmination of our decades of experience. A lot of what we learned over the years with the TriStar based systems led to the GenStar, and as we'll talk about in a moment, you know, bringing a lot of this functionality to the rest of the product line and kind of bringing things full circle. So yeah, pretty unique approach to building systems and a compact form factor that builds in a lot of I/O that you wouldn't otherwise have. So let's talk about that I/O for a minute. The GenStar data sheet, one of the points that was often overlooked in the early days was that it has a load terminal built in. So it can drive DC loads directly from the wiring terminals on the product. If you need to go higher, 30 amps doesn't cover everything. Then you can install a ready relay that is embedded on a DIN rail that comes with the product to drive a larger relay or a contactor to run a pump or just a larger continuous DC load. That's become a really common use case. There's more to say about the ready relay. We'll talk about that in a little bit more detail in a moment. But suffice to say, for the purposes of the GenStar, it's a really handy load management option, and you can use multiples to build some fairly complex load management schemes. Um, Also unique to the GenStar is just the way that the connections are all sort of common to the bottom area. So sort of conducive to building, think of it as like a cable tray or wire management, keeps things really clean. Anything that has to do with the communications and the power is going to be routed down through the bottom of the product, through some pretty heavy lugs and really well built and high quality interfaces so that you're building you're connecting it once and sort of walking away and forgetting about it and not being worried about connections becoming loose and such. So this is just a general overview. The Ethernet, the remote temperature sense, the voltage sense options, and of course the communications interfaces are all integrated. And then of course the reason you're using them is to take advantage of interoperability with different systems. The most common, maybe let's say, across all markets is Bluetooth, obviously. Pretty common and ubiquitous these days. The GenStar makes that possible, makes the connection to the Android app possible, the Apple app, the iOS mobile app possible through that Bluetooth connection. But we haven't lost our roots. We still support that industrial Modbus, either Modbus RTU or Modbus IP connectivity. And pretty unique to Morningstar is also the connectivity through an SNMP protocol, which is really the industry standard for telecommunication systems. So all that comes along for the ride with just the hardware. And then a really nice feature that we'll talk more about, and I'll show you kind of some screen captures of, is the built-in live view UI. That's a web server, a built-in web server, and a browser-based interface to configure and manipulate and monitor and set up your product. So here's where we can talk a little bit more about those Ready Rail accessories that I mentioned, the Ready Relay. It's effectively two dry contact channels that have independent control. When you connect that Ready Relay into the GenStar, it automatically configures, it recognizes it, becomes part of the software environment, gets its power, conveys its data through a proprietary data bus. So there's really no configuration per se, other than what you want to do with it. It just slots into that DIN rail within the footprint of the product and becomes a part of the GenStar. So the idea is that you can mix and match these Ready Rail accessories as needed. The other angle to that line is the shunt. So effectively, the Ready shunt is when paired with a brass, 50 millivolt shunt. We offer a 50, a 100, a 500 amp shunt. You also then have the functionality of a smart monitoring device that can be used for various purposes. And the Ready BMS is just as it sounds, it's a BMS battery interface that can be used to either just read data in an open loop sense from a lithium battery, or fully integrate with certain manufacturers in a closed loop setting. So here's a deeper look at that ready relay. It's, like I said, two relay channels, dry contacts. It handles up to 6 amps itself, but could also be used to drive a larger relay if that's not enough power. And it can be used as either just a simple on-off, like in a load shedding scheme, kind of an LVD mode, or you can build some more complex Boolean logic triggers to say, for example, if the solar array is not producing, an average amount of power, shed some loads that may not be so critical. So there's a lot of I/O and configurability and control that you can do with this product. Same with the shunt. Out of the box, the shunt itself is the blue box, the blue block. The shunt itself is sold as a separate item or as a kit. And so you can mix and match these shunts. It's important to pick the right shunt. I would always want to point out that the accuracy of the shunt is most tuned when you pair the rating of the shunt with the load. So, for example, if you had a load that you expected to run, or charging current from another source that was between 10 and 30 amps, you'd probably want the 50 amp shunt, because you'd have better resolution and better accuracy within that range of current. But for something like a net shunt system where you're trying to measure hundreds of amps of total charging current or output current from a battery bank, you'd move up to the 100 or the 500 amp shunt. But the shunt itself works with either all three of those, really any 50 millivolt shunt off the shelf. I guess the one thing that this really brings to a system that didn't exist before is the ability to use the shunt in a net sense to measure energy in and out of the battery bus. So that can then be used to determine an actual accurate state of charge for a given battery bank, and in a percentage terms as opposed to just a voltage-based approximation. So it's a really powerful tool, especially when paired with the Ready Relay. You now have control and measurement all kind of in one package. And then the BMS is, like I said, open loop monitoring, for reading data from a BMS, and with some manufacturers doing a closed loop setup where you're really giving control to the battery to tell the GenStar or the attached device what to do with it. And then my favorite part, the GenStar centralizes all of that data in a few different ways. So if you're just looking for a local wireless Bluetooth to your phone or to your tablet interface, the mobile app is a great choice. You have flexibility to, view that live view UI in a mobile native format. It's a really, well-designed app for either iOS or Android. It's not some kind of some apps are like a web page approximation. This is a really nicely designed UI that's snappy and flows well. Allows you to do things like just view the basic data that's happening in the system, but also update firmware to the controller, just through that Bluetooth connection. Takes a little while. It's not the fastest, but it's really convenient. Then you also have the live view interface. That's the web server. So if you connect your GenStar to a router, to your local network over Ethernet cables, you're able to take advantage of a very, very powerful UI to monitor your system locally. And then now, for the first time in the GenStar natively with the firmware update to version 4 or higher, you also get Solar Connect, which is brand new, just coming out to the GenStar, where you now have effectively a full cloud enabled copy of the data that's being sent periodically, pretty good resolution to your account, secure over industry standard, cloud security protocols. So all three options come with the GenStar. The app itself, as I said, is pretty snappy, both Android and iOS. Probably the most common way to get started with a system and make sure that the firmware is updated before you move on to something like the live view page. Um, Once the system's up and running, once you've powered on the controller, maybe you've connected ready blocks, everything auto configures and walks you through kind of a setup procedure, a commissioning procedure. Pretty intuitive. We've got a lot of good videos and resources to help walk you through that. It can be overwhelming if you're not familiar with exactly what all is included. So always give us a call if you have any questions. But I think over the course of a few systems, you should get the hang of it. Um, Most important thing to note here with Live View is that there's a really powerful data logger. There's a lot of, maybe even too granular data for the average user, but we record everything and make it exportable in a CSV. Sometimes that's helpful in troubleshooting, either just independently or if you're working with our support team, having access to that full data log of all the voltages, temperatures, currents, things like that that are recorded every day can be a really powerful tool for troubleshooting when a system isn't performing as intended. And then one step deeper is the event log. And this is definitely an advanced area where, a lot of kind of internal state changes, faults, alarms, and such are time stamped and logged into memory virtually indefinitely for us to, help to troubleshoot if something really goes awry. So just to wrap that up, again, just a nice visual of what all connects into that integrated series product. We talked about different battery chemistries. We talked about the ready rail system, all of the network interfaces that it can connect into via Modbus or SNMP, the shunts, the lithium BMS interfaces. One thing we didn't talk about much is the genset. There is a really powerful generator that's also a generator control interface that's kind of become a product in itself. It's pretty in depth. There's not a lot you can't do to control a generator. I guess the best way to summarize that aspect of the product is to say that we can do a lot to turn a generator on and off, but it's not a full substitute for a deep sea or some kind of a direct generator controller that's embedded with diesel glow plug timing and such. It's really more of a trigger, but can be pretty helpful and pretty powerful in terms of the logic that can be used to decide if and when and how to turn the generator on and off in coordination with the different solar aspects of the system or battery states of charge.
Kyle, on the live view topic, is the GenStar the only product that can access live view? Is everyone else still on MSU?
I know that wasn't a plant, but that is a perfect segue to the Ready Edge section. The live view interface, let's go back to that. So live view was, yeah, I guess as you mentioned, the replacement for, you might say, the MS View PC-based utility that is still very relevant, still works, still is used every day to customize the professional series products. But Live View became or is becoming, our standard interface, and that is driven was developed for the GenStar, developed for that particular product line, but you can think of it as being ported into the OS, the operating system of the GenStar, including LiveView, is what ReadyEdge delivers sort of first and foremost. So ReadyEdge is, one device that stands alone. You might think of it as an accessory product. It's definitely not a charge controller, although there's a lot of control aspects that it can provide. Um, its purpose is to connect various Morningstar products and third-party devices. Provides much of what you see here. You could think of the Ready Edge replacing the GenStar, but in coordination with the Morningstar Professional Series product line, with some enhancements and additions that we'll talk about. So it is, as I said, a standalone product. It is a relatively small, about six inch by 1.5 inch deep by 4 inch tall box. It's DIN rail mounted. It has various inputs, voltage, three different voltage independent DC voltage inputs, two temperature inputs, a tank level sensor, just a resistive tank level input, six digital inputs, And then on the bottom is really where we configure the outputs. So we have uh, the 12 volt output to power typically the RS-45 bus, which needs 12 volt power. There's an AC detect circuit. You can bring in AC power from some source. There's a couple of specific use cases for that we'll talk through. And then you have your communications ports, Ethernet, meter bus to connect to Morningstar products. And then for future use, Morningstar CAN interface, which will have some pretty interesting use cases once that's fully developed. Really wide power input rating, 8 to 72 volts, so suitable for 12, 24, 48 volt nominal systems, and a really wide temperature range, minus 40 C to 60 C. But it is indoor rated, just like the vast majority of our charge controllers, and needs to be installed, in accordance with those provisions for indoor use products, meaning inside of an enclosure. So there's just a deeper look at the bottom. We have the power input on the left, the 12 volt DC out. It's only rated for 1 amp. It's not intended to be, a power supply, but it is a nice, um, simple 1 amp output signal to give you either power to that 485 bus, which typically needs 12 volt power, or it can be used in a generator starting application in some cases. So what is Ready Edge and why do I need it? It's everything that the GenStar delivered, but without the charge controller. It is the intelligence, the monitoring, the user interface. It's a way to bring your data to life out of other systems. And I say other systems because it doesn't necessarily mean a Morningstar system. It's the first product you might say that we have developed that could be used standalone. It doesn't require a Morningstar charge controller. It will often be paired with other Morningstar products, but I think we'll find uses as a standalone generator interface, for example. It may just be that the Ready Edge is used to monitor an off-grid system that has existed in the field for 10 years. It could be added as an enhancement or as part of a retrofit or refurbishment to bring data connectivity to that site. And if it's connected to a Morningstar product, you could think of the data set as being enhanced, but not necessary.
So another note there. So if you had a whole bunch of off-grid systems that you take care of in the field and they all have
Mhm.
different vendors associated with them, you could also like homogenize it all into one platform.
Absolutely, yeah. I won't name any names, but yeah, the sky's the limit. Um, a system that's already been, you know, paid for, commissioned, fielded, tested, it's running fine. Please don't rip it out and think that Morningstar's trying to force you into our ecosystem. I mean, if it's time, sure, there's enhancements that could come from adding a TriStar or a GenStar as compared to what's there in the system. But otherwise, yeah, think of Ready Edge as wrapping around the existing equipment. Um, just to clarify, though, there's not any intention for us to, like, let's say, write drivers for third-party equipment. It's just analog interfaces to look at voltages, currents, and such through the Ready Rail accessories, for example. But there's not any direct digital communication with those other third-party devices. Um, you effectively get that live view interface and the cloud if you choose to enable it. So in that sense, it can act as a system controller, not quite a full PLC, but something that's approximating a PLC or a PLC light. So first, it's about connecting the product, the data from the site to a usable interface, whether that's through a Modbus connection, an SNMP protocol, or our live view web browser, or the cloud. All of these are simultaneous, um, let's say, interfaces that can be used in coordination with one another, and that's a pretty powerful combination. So you can have imagine a backup, internal monitoring platform for let's say, deeper troubleshooting through that live view data logging, fault recording, event recording system, but also have the Modbus SCADA system connected to just a few variables, polling a few variables periodically. So there's any number of ways you can imagine to use those different interfaces, but it's all there under the hood. Um, the app comes along with this, so the Ready Edge also has that same Bluetooth interface, enables the Morningstar mobile app to do that same kind of quick at a glance monitoring or configuration, and will support in a very near future update for more updates to the connected device. There's a few exceptions to that. I think the SunSaver MPPT being one, but that firmware hasn't changed in 10 years anyway. But so it's a pretty robust data ecosystem. The same trends that are recorded in a GenStar have come over under the Ready Edge umbrella, daily histories, mins and maxes and such. Um, I won't have time to get into a demo, but I will post these links into the chat before we end the recording so that you can poke through those demos yourselves at your leisure. There is one live on our website for live view, it's just a simulated version of what you'd see if you had a connected controller. And also the Solar Connect interface itself is live. It is open, even without a device. You can register. You won't see much when you're there, but we can give access to some various logins if, for example, Charge Solar, you guys wanted to start to work with some of your customers to test drive Solar Connect. We can get some accounts with real data embedded to take a test drive of those two systems. Just to round things out, I wanted to give you some insight from our view as to how you might connect Ready Edge with some other products, whether they be Morningstar or others. Here's an example of doing so with a data-enabled controller, a product that's connectable via meter bus. You'd be able to pull all the data that the SunSaver MPPT is compiling itself into the Ready Edge interface, and view that in one place. But if you didn't have a data-enabled product, just an old SunSaver that's been in the field, you had a Ready Edge, through those voltage inputs and auxiliary temperature measurement inputs, you could at least look at battery voltage, solar voltage, load voltage, et cetera, through that analog interface. Um, as I mentioned, there's a lot of functionality to go beyond measurement with the tank level sensors, looking at the ability to detect whether AC is present or not, has some interesting applications. And all of that kind of rolls into that same live view dashboard so that you can set up triggers and alerts and alarms to show you when a condition has been met, whether there's a fault, whether there's some kind of a voltage threshold that's been reached. Probably one of the most useful features that we've already seen have some pretty solid use cases in the field is through just the AGS function, coupled with that AC detect circuit. So the idea here is that the Ready Edge not only could be programmed to set the conditions under which the generator needs to start. Battery voltage gets low, turn on the genset. You can also have a feedback loop to know that it actually started through that AC detect circuit. Unique to the Ready Edge, different from the GenStar, is the set of 6 digital inputs that are viewable on the live view dashboard. Use your imagination. The sky's the limit on how those could be used. But suffice to say that it's pretty simple interface to label them with some common language to know which input is wired to which device on the outside. Can get into some pretty significant and substantial schemes with the Ready Edge and the legacy controller design. When you look at systems that might need to incorporate external charging sources, that's where some of the functionality of the Ready Shunt comes into play. You can imagine using a third-party, charging device, but wire a SunSaver, rather a Ready Shunt in line with that AC/DC converter, that power supply, and know what additional charge is coming to the battery from a non-solar source. Pretty interesting, ecosystem to work with. It's kind of the subject of its own webinar. We do have some recordings on some pretty deep dives with regard to compatibility and use cases around these blocks. But the Ready Edge is the bridge to that ReadyRail ecosystem to start to add the functionality of those three blocks to uh, systems that might use the TriStar or the ProStar. Again, there's just an image of how it's, how it might be deployed. Similar to the GenStar, it's DIN rail mountable. On the right side of the ready edge, the product comes with a sufficient length DIN rail to be able to mount 3 ready blocks, but that can be expandable to 6. So you have a lot of combinations that you can fit into a single package. And then again, just to summarize and round things out, these are the data-enabled controllers, the meter bus enabled controllers that pair with Ready Edge quite easily over that meter bus connection. Practically, up to 16 devices is the limit. That would be a pretty large system. Only a few in the world probably get up to that level. So we'll cover virtually anything I think that's been fielded over the years with our professional series product line. So the Ready Edge can bring them kind of into the new era. Think of it as the bridge to the integrated series for the professional series product line. I know that was a lot. We'll end there and take any questions anyone may have, or certainly I'll be available after the fact as well if anything pops up through Travis or Amber. I'm happy to answer any questions you might have offline. Thanks, everybody.
All right. Thanks so much, folks. Enjoy the rest of your day.